Assalamualaikum warahmatullahi wabarakatuh, and hi everyone. I am Nur Sabrina binti Hilmy, matrix number S60079. Today I will be presenting about ocean ion fertilization. Okay, so what is ocean ion fertilization? It's an effective method where intentional addition of iron to the ocean surface to stimulate phytoplankton production. This is done to boost biological productivity in iron-limited, high nutrient, low chlorophyll regions and speed up carbon dioxide sequestration in this area. The flow of micronutrients such as nitrate, phosphate and silicate from the deep ocean into the mixed layer, which lead to new production, determines the effectiveness of the biological pump. How did Martins come to this finding? Martin discovered that iron was found in trace amounts only in the Antarctic Ocean, the equatorial Pacific and the Gulf of Alaska. He assumed that the only iron in these locations came from dust carried across the oceans by the wind. In these areas, phytoplankton never blooms. He set out in 1989 to put his theory to the test. He sent 3 lab technicians on a study cruise to the Antarctic Ocean to conduct a small-scale experiment. Plastic bottles were filled with phytoplankton and seawaters. They added iron to some of them. They also added nothing to the life of others. They then placed them in the sun to dry. So to be concluded, Martin hypothesized that increased dust intake relieved iron restriction, improving biological activity in HNLC zones during the last glacial maximum. This is because dust input is often regarded as a significant natural iron source for iron fertilization. Okay, next, how did they know about the atmospheric gas composition in ancient times? The atmospheric carbon dioxide during the last glacial maximum was revealed by the analysis of trapped air bubbles in Antarctic ice cores. They were able to measure how much carbon dioxide and other gases were in the atmosphere when the ice formed. During the last glacial maximum, which was about 20,000 years ago, there were approximately 180 parts per million of atmospheric carbon dioxide, while during the pre-industrial times, approximately 280 parts per million of carbon dioxide were produced. The first objective is to induce a strong phytoplankton response to reduce atmospheric carbon dioxide levels, and the second objective is to stimulate marine carbon sequestration via the biological pump in iron-limited, high nutrient and low chlorophyll HNLC zones by seeding the ocean with iron, causing phytoplankton to grow instantly. It will also absorb dissolved carbon dioxide in water, releasing it into the atmosphere. So these are 3 areas where iron fertilization occur, which are subarctic North Pacific, equatorial Pacific Ocean and also Southern Ocean, and they are known as high nutrient and low chlorophyll regions. Except for subtropical North Pacific, it is located at low nutrient and low chlorophyll region. Phytoplankton and primary production in HNLC areas are relatively low even with high nutrients. Despite the high availability of macronutrients, which is nitrate and phosphate, these regions are considered high nutrient and low chlorophyll. So actually, iron and also climate change have a relationship where Martin proposed that high iron levels could be an effective way to stimulate oceanic carbon sequestration via biological pump, as iron acts as stimulant, causing phytoplankton to bloom. Because phytoplankton consumes so much carbon dioxide during the photosynthesis process, atmospheric carbon dioxide levels fall. The process of photosynthesis dissolve organic carbon and nutrients. Upwelling processes transport nutrients. The effectiveness of organic material transfer is determined by macronutrient uptake, increased absorption of dissolved inorganic carbon due to increased oxygen production. As a result, atmospheric carbon dioxide levels will fall. So from this slide, throughout the ocean iron fertilization experiment, from 1992 to 2010, there's total of 6 natural ocean ion fertilization experiments and also 13 artificial ocean ion fertilization experiments. However, every experiment will have their own limitation. For example, in equatorial Pacific, there are insufficient experiment duration, single ion addition, no export flux measurement in deep ocean, micro and macronutrient limitation, and also subduction of fertilized patch. For subarctic North Pacific, the limitations are insufficient experiment duration and also single ion addition. And for the Southern Ocean, there are insufficient experimental duration, light limitation, high dilution rate by small patch, entrainment of dissolved silicate into fertilized patch by physical mixing, and also no direct measurement of export flux with sediment traps. The next question is, are all these experiments achieve its main aim? Well, based on the overall experiment results, all of the experiments failed to meet the expected outcome with the exception of effects results. The production of aggregates with rapid sinking rates, there is significant carbon export to deeper layers up to 3,000 meters below the surface. The majority of artificial ocean ion fertilization experiments have resulted in an increase in phytoplankton as well as macronutrients and dissolved inorganic carbon drawdowns. However, their effectiveness in increasing export production has not been demonstrated. Except for effects, everything is confirmed. Several issues arise as a result of the introduction of iron into the study areas, such as lower biogeochemical response, with no discernible changes in the carbon flux were not detected during the experiment. Next is improvement that can be made for the future, such as the scientists can improve where they want to perform the experiment, the time to perform the experiment, such as they need to choose the best time, the best season, so that they can get the best result for the experiment, and also the duration for how long they want to carry out the experiment. They need to also improve the effective tracing and the strategy on how they're going to carry out the experiment, and also monitoring the possible effect of the experiments. And this are the list of reference for my presentation, and that's all from me. Thank you.